say you running on the road, so get out the way.
Hey everyone, welcome back to the AI Cowboy. Today I'll be discussing what is semantic search, how we can use it to make traditional search bars better. So, semantic search allows us to use semantics instead of strict searching. So, let's take a look at an example. So, I have a data set with NBA teams and their cities. Um, Let's look at a traditional search bar. So Excel has one baked their into their column lookup. So what we can do is we can type in Chicago, and it Chicago should come up. That's good. But what about any? Let's look for any cities with ski areas. Nothing comes up. Why is that? Excel uses a strict search. So if it doesn't line up exactly with what's in here, then it's going to it's not going to return any results. There's nothing wrong with that. It's just how their functionality is. And so one thing we could do is we can introduce semantic search and provide context clues to make searching better. Um, so the data frame that we're going to be using has this extra field called concat, which is just a simple concatenation between these two columns. Why did I do that? Well, we provide extra context to not only the city, but the team. So I can look for Steph Curry and the Warriors should come up, and we'll test that out. I'm going to, and now we're going to save this. We're going to upload it to this Streamlit app. So I built this Streamlit app, and the GitHub link is in the video description. But I'll go through the code too. We'll just upload the file first. I'll show you how semantic search works, and then we'll talk about the code. Okay. So in this app, you upload your data frame. Then you want to pick the column you want to search for. Let's do the concatenation field because we can provide quite a bit of context clues in there. So let's look for ski areas. Yep. Oh, that's interesting. Denver is a little bit further down than I expected, but Utah comes up first. That's pretty interesting. Okay, let's try Steph Curry. Again, no Steph Curry in this at all. So what's happening? So we can go ahead and look at the code here. What we're doing is this first part of the code is creating a caching mechanism so that our searches are faster. So anytime we have this column vector that is cached with embeddings, and then we also have the search, the what you search for cached in an embedding. So once you upload the file, you enter in the column you want to search on, and then you enter the text. So here is the column that you want to search for, and then here's the text that the user, would personally enter in. From there, we create this embedding from string. What this embedding from string is doing is it's first going to look into the cache file to see if we've already done this. There's no reason to go get an embedding if we don't need to. Otherwise, it's going to go to OpenAI. It's going to talk to ChatGPT and say, hey, can I get an embedding for Steph Curry? It's going to return a number. And so we're going to have one number for Steph Curry, and then we're going to have 32 numbers for this data frame, the column that we're searching on. I believe it's 32. Okay, 29. 30, sorry. So we have 30 embeddings for this column and then one embedding for this column. The next thing we do is we do what's called a cosine similarity between the Steph Curry number and then the concatenation. From there, that cosine similarity is going to return the score. And so we want to keep all the score, we want like the top 10 scores in this case. So the power behind this is obviously OpenAI's embedding. So OpenAI has trained ChatGPT on public data from the internet that gets stored as information in the model. The model then looks at Steph Curry, provides an embedding for it, and it has a very strong embedding with this Golden State Warriors, which makes sense. And hence, that's why it's the top search result. I hope you find this video helpful on what semantic search is, and I encourage you to play with the Streamlit app. Thanks.